And then it's like chronic lymphoid. Oh, okay.
Thank you.
Oh, no problem.
All right, so this would be a comparison between normal blood. Note up here, the majority of what you see are the red blood cells. But down here, the majority of what you see are white cells and then almost destruction of those red blood cells in the leukemia one. So white blood cell counts usually are high. Something else that you might hear a clinician say, let's do a CBC. Let's do a complete blood count. In a complete blood count, they look at the hematocrit, they look at the hemoglobin concentration, they look at the count for the red blood cells, the reticulocytes, white blood cells, and platelets. We can have that differential white blood cell count be done, and they'll also, if they need to, they can look at the size of that red blood cell and what's the hemoglobin concentration. Now, why would this need to be done? What would be the purpose in this? Why would we need a CBC?
To diagnose a disease.
If they're having difficulty with something, maybe it's their oxygen level in the blood, okay? They might could do the CBC for the oxygen level. Maybe they don't know what else might be going on with them. Maybe they want to see, are the red blood cells in the right amount? Are they in the right number? Doesn't have to just deal with the white blood cells. It can affect or be in relationship to the red blood cells. It can be in relationship to the hemoglobin, okay? Maybe they want to see if, if the red blood cell size is correct, then most likely its ability for the hemoglobin to be present is good. But if the red blood cells tend to be decreased in size, chances are that they don't have the correct hemoglobin and therefore not a good function for the oxygen transport. Okay? So there are lots of reasons to do the complete blood count. And we know that the numbers, there's a norm for the numbers. All right? So if you look at the hematocrit, for example, okay, we know that for males, it should be about 4.6 to 6.2 millions per microliter. For females, roughly about 4.2 to 5.4. So we have norm values of all of these particular tests that can be run. And if something falls out of range in those tests, then we kind of know where to begin looking for what might be wrong. Now the next part of the blood that we need to talk about are the platelets. Platelets and hemostasis, the control of bleeding. What's the consequence if we can't stop bleeding?
Die.
Pretty much. I mean, if we can't stop bleeding, the process begins a positive feedback cycle. Now at this point, maintaining homeostasis has been based on negative feedback. At this point, if bleeding begins and it cannot be stopped, it doesn't move into negative feedback to try to control it. It moves into positive feedback, which will feed the cycle and keep the blood flowing. Seems kind of odd, doesn't it? All right? So one of the things that we do, all right, if that positive feedback cycle, and in that positive feedback cycle, it leads to a continued decrease, 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 decrease in the blood volume. Because if you've got somebody who's bleeding and you can't stop the bleeding, that still thinks it's supposed to produce the blood, bleed, 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 you're decreasing and decreasing and decreasing that blood volume in that person. And yes, that's going to lead to death. So when we have to stop the bleeding, hemostasis is what it's termed. The fatal leaks. Think about an artery, all right? When someone is having excessive bleeding, we of course term that a hemorrhage, all right? And we have 3 mechanisms that want to try to stop bleeding. We have a vascular spasm, we have platelet plug formation, and then blood clotting, or what we know as coagulation. This process is a very important way to maintain homeostasis. Throughout every day, 24/7, 365, 366 if it's a leap year, all right? You're going to have constant tiny little breaks throughout the vessels of your body. And you don't even know it, because this process is taking place and it's helping to maintain the homeostasis. Now, in a situation where there's a breach to the outside environment and you begin to have the bleeding out, okay, the one thing that you want to do is help prevent excessive blood loss. Now, the body is going to have a way that it's going to work to do that, okay? The body is going to have those 3 steps, okay? That vascular spasm, that platelet plug, the blood clotting, all right? Now, platelets, are they a full, true cell? No, they're not, men, are they? They're little pieces, okay? They are tiny little fragments that are floating around in the blood, okay? But their job, oh my goodness. They have a huge job, okay? They're small fragments of a cell called a megakaryocyte. Mega, big, karyonucleus, a big nucleus cell that basically just sits in the trabeculae of the bone. And as blood flows by, it'll grab a little piece. Another little piece will get grabbed, and another little piece, and another little piece. And those are our fragments. Pretty cool, okay? They have a very complex structure. And they have an open, canalicular. Do y'all remember canaliculi? Becca, you're shaking your head, yeah. From where?
From within the bone structure.
From the bone cells. The bone cell sat in its lacuna in one lamella and communicate it to the next one by way of these little tunnels, the canaliculi. Okay? They're going to have a canalicular system. And these teeny tiny little itty bitty platelets. They have their amoeboid movement and phagocytosis. A normal platelet count is anywhere from about 130,000 to 400,000 per microliter. Now, that number sounds high. I mean, don't get me wrong, if somebody gave me that many dollar bills, I wouldn't turn it down. Okay? And you would think a microliter. I don't even know, you guys. Okay, I could go look it up. All right? That there would be that many in a microliter. Seems kind of high. All right? But now remember, extremely, extremely tiny. This is what they do. Secrete vasoconstrictors that will help reduce blood loss. Stick together to form a platelet plug to seal small breaks. Secrete procoagulants or clotting factors to promote clotting. Initiate formation of a clot dissolving enzyme. Whoa, wait a minute. They're going to secrete clotting factors to promote clotting, but then initiate clot dissolving? Wow. Okay, interesting. Chemically attract neutrophils and monocytes. The ones that will come in and just eat. Something that's going to be what they consider foreign to any type of site of inflammation. Phagocytize and destroy bacteria, secrete growth factors that will stimulate mitosis to repair blood vessels. From that teeny, itty bitty, tiny, little, not a full cell platelet. Take a break. You guys, 12:30. Think about platelets on your break.